Hello, everybody. My name is Daniel. I'm the strategy engineer at Astronomer.io. I'm a PMC of Apache Airflow, and in a past life, I helped lead the effort for the Kubernetes executor. And I'm really excited to show something that I think is going to be over the next year or two really revolutionary in the project, which is the Astro Python SDK, which is essentially a new way to kind of really widen the scope of people who can use Airflow to data engineers and data scientists, and really just kind of rewrite the Airflow DAG writing story from scratch. So when we think of Airflow, especially towards the beginning, one phrase I've heard is that Airflow was written by data engineers for data engineers. And I think this is pretty accurate. You know, one way to kind of think about this is that Airflow came out around like 2014. Like that's when it first started at Airbnb. And essentially, this was in the heyday of the Hadoop/NoSQL revolution. So essentially, you know, everyone thought SQL was dead. Everyone thought like, oh, NoSQL is the future. And, you know, our better solution was that we started having to package jars and do bash commands and do all sorts of pretty low-level things to actually get our distributed jobs to be done. And so with that in mind, when Airflow came out, it made a lot of sense to have this really low-level control at the DAG authoring level. And that was great for that use case. It was the best solution at the time, but it also created kind of an interesting issue going forward, which is that Airflow has a bit of a learning curve. You know, there's a lot of Airflow-specific terminology you need to understand to get your DAGs running, which, funny enough, once people get over that learning curve, you find people saying that, oh, Airflow is not that hard, like, you know, it's so simple to my workflow. But it's still that for someone who's coming in from scratch, especially someone like a data scientist who may not live kind of in that deeper core engineering, infra engineering level, things like XCOM, bit shift operators, and like understanding what like a sensor is, these are all things that are kind of not how a data scientist would think. You know, you have people who instead want to think in terms of data transformations and think in terms of moving your data from one place to another. And so, you know, I'm here today to say, guess what? Airflow isn't just for data engineers anymore. And we're really excited to introduce a new product that's going to make life a lot easier, both for the data engineers who are supporting a lot of data scientists and analysts, and for the data scientists and analysts themselves. And this is the Astro Python SDK. And essentially, this is a way of reinventing the Airflow DAG authoring story. And what we're essentially going to go over is that this new library allows for self-documenting database agnostic Pythonic code. And it really kind of creates this concept that you can have SQL tables and Python functions and data frames all kind of living together. So you can, SQL and Python are the two most common languages for data science and data engineering. Therefore, why not use these two languages in a way that they communicate with each other really easily? We also wanted to really simplify the load and export stories, because when it comes to pipelines like ETL and ELT, a lot of times that's kind of the nastiest part in terms of where a data scientist might need to depend on a data engineer is during that EL stage. So how can we make it as easy as possible to load data into your data warehouse so that you can start focusing purely on the transformation layer of your data pipeline? So what is the Astro SDK? Well, it is the fastest way to get started writing DAGs. We're starting with ELT, but we do intend to kind of spread out into other use cases. But we wanted to kind of focus in and say, hey, you know, Airflow is a really versatile tool that can kind of do anything. What if we could build specific tool sets that make very common use cases really easy? So it's only 8 Python functions and 2 classes. It works on top of OSS Airflow. So this is not an Astronomer specific product. You can be running, you know, MWAA, you can be running Airflow completely open source. You pip install this library, you now have access to all of the Astro SDK, and it actually works with traditional Airflow DAGs. So it's actually, these are still Airflow tasks. So you can still set dependencies between Astro SDK tasks and say you have like a pipeline that needs a bash operator halfway through. You can still like chain together your Python functions, SQL functions, as well as a bash operator and still have a cohesive DAG. or integrate Astro SDK tasks into a traditional Airflow pipeline to slowly shift things over. So we're starting out with ELT, and a big reason why is that ELT in Airflow has not been necessarily simple so far. So like, let's say you have like a pipeline where you're pulling data from S3 to Snowflake, and you're trying to do a series of Snowflake transformations. Well, if you're doing this with traditional Airflow, you kind of have to own every step along the way. You either need to be kind of populating pre-existing tables, or you need to manage creating temporary tables for every step in that process. So you're loading data from S3 to Snowflake, that's a temporary table. You're filtering it to kind of get rid of the null values, that's another temporary table. And that can get quite cumbersome, both in terms of cleanup and in terms of how the actual SQL queries end up looking. So we wanted to simplify that. And so now we have this really simple Python API where it's like, cool, you want to load a file? Use the load file function. You want to transform the data? Use transform. You want to merge it into an existing table? We have a merge function too. And so every step along the way, we want to make this as easy as possible for the actual DAG author, while also empowering those infra level people to write out mini libraries that can simplify, allow a small number of data engineers to support a large number of data scientists and analysts. So to kind of go through what this looks like, we wrote up a use case. And the use case is, I am a data scientist on a marketing team who wants to perform a sentiment analysis of Reddit posts about Airflow. I need to get raw data from the Reddit API, put it into Snowflake, clean it, pass it through an inference model, and then merge the results to a reporting table. As you can see, this is a pretty straightforward linear pipeline. All of this still works if you want to do like multiple inheritance and parallel processing. But to start out, why don't we just start out pretty linear? And so extract, filter, analyze, join, and load. And so let's start with the extract. And the extract and load step of Airflow is, cool, how do I get data from S3 into Snowflake? Well, in this situation, if you're doing things from scratch, you first need to create your own temporary table. So you need to use the Snowflake operator to run a SQL query, define the whole thing out, and then use a Snowflake con ID. And then you have to actually hope that there's an existing operator that can actually move your data. So someone has been kind enough to create S3 to Snowflake operator. If you're moving from GCS and there's no GCS to Snowflake operator, you're going to have to pretty much build your own operator from scratch, or you do something with the Python, like you do something with the Taskflow API. So it's kind of like you don't have this kind of native feel to it. And it's worth noting that these two tasks don't have anything to do with each other until you explicitly state that you are setting this dependency using the bit shift operators. So that kind of feels like, great, I'm creating nodes and then I'm creating a graph. And data engineers and data scientists don't think in terms of nodes and graphs. They think in terms of data transformation. So with the Astro SDK, we have the load file function. And so load file function is pretty straightforward. It's cool. Give us the file you want to load from, and give us the table you want to load it to. And files and tables are first-class citizens in the Astro SDK. So in this SDK, the file, both of these are essentially pointers, but they're pointers with enough metadata for us to understand how to process this. So a file can be local, it can be a remote object store. We currently have experimental support for HTTP endpoints, but with that file object, we support all sorts of formats like CSV, ND, JSON, Parquet. We can then convert those for you using so you don't have to think about those conversions manually. We also have the table object, which points to a table in a data warehouse. So that's Snowflake, BigQuery, Postgres, Redshift, those types of places. You give us the connection ID you would already be using for Airflow. You give us the name of the table you want to pull from. Or if you don't give us a name at all, now you have a template for creating temporary tables, so we know where to store those temporary tables. For those of you who tuned into the Airflow Summit talk, I'm sure you remember that before, the load file function was a little bit more experimental. It wasn't ready to be used at scale. And now we think that we're ready for some pretty good scale. So we've tested In customer interviews, people often said that they pretty much max out about 5 gigabytes per DAG run. So we tested it at 10 gigabytes, and we found pretty comparable results to using the native methods, things like BQ load or the Snowflake copy function. So we're pretty happy with these results, where you can get like a 5 to 10 gigabyte pipeline running on a pretty regular cadence, and this will not be a major source of slowdown. So now you have one function that handles all movement of data from blob storage or local storage into Snowflake, BigQuery, etc. But what if you don't have a data warehouse? What if you're a more Python specific team and not necessarily a SQL team? Well, if you run the AQL.load file and you don't give it a table, it actually returns a data frame. And that data frame can be passed into the AQL.dataframe function, or it can actually be passed into traditional TaskFlow API tasks. So you can actually just load a file, pass it into a TaskFlow task, and then be kind of in the more traditional Airflow ecosystem. So now let's talk a little bit. So you've loaded your data into your Snowflake or your BigQuery, and now you want to actually run some transformations on that data. Well, in traditional Airflow, again, you have to use the operator. And so this is also, keep in mind, this is further vendor lock-in. So if you're using the Snowflake operator and you want to switch your stuff to BigQuery, well, now you have to go through, change all your Snowflake operators to BigQuery operators and figure out where all those differences are. And basically, changing their data warehouses breaks all of your DAGs. With the Astro SDK, we wanted people to be able to shift between data warehouses a lot easier, which we'll show in a minute. But so you start with the Snowflake operator. You then have to manually create the temporary table and then add that select statement as like a secondary aspect. You also have to use F strings, which are actually pretty unsafe security-wise. And then at the very end, you have to specify your task dependencies, because again, none of these things are actually like working together as data. They're just kind of tasks that you have to join together manually to let Airflow know what the dependency is. With the Astro SDK, now we have the AQL.transform decorator. So you can basically create Python functions, insert a SQL statement into that Python function, and we will, using Jinja templating, we will automatically move your data. Like we will automatically take any parameter and we'll handle the safety of it. So if we know it's a table, we'll treat it like a table. If we know it's not a table, we'll treat it like a safe object to make sure that there's minimal surface area for SQL injections. And once you've written these functions, you can actually pass them to each other as if they're just regular Python functions. So you can create a table, pass that into one function, pass that into another, and Airflow automatically sets the dependencies. We also have this feature called the output table parameter, where at runtime, so you don't need this parameter in the actual function definition, but at runtime, if I said, I'd actually like to name this table, I would actually like to create a table that lives in perpetuity. You can state what the table name should be, or you can say, I want to move this table into a different schema, and you can create an output table that has a different schema. And so you have control over where the output of these functions actually goes. And again, you can use full Python functional composition. So everything here is treated like normal Python functions and objects. And where that gets really powerful is, let's say you're a data engineer and you have a team of 10 that's supporting 100 data scientists, and you need to build libraries or DAG generators to help your data scientists not have to think about lower level concepts. Well, now you can actually create a series of functions using this decorator, and you can actually abstract a lot of the SQL functionality out and offer a library to your data scientists where they can then focus more on like how the actual data movement should work. We also offer a AQL.transform file. So, the AQL.transform is really valuable in a lot of ways, especially for simple CI/CD. If you want to keep everything in a single DAG file or make a library, it's really valuable there. But of course, you might have a case where you have like a 100-line SQL query, and you don't necessarily want that 100-line SQL query in your DAG file in a Python function. So the transform file function allows you to point to an external SQL file and we'll do the same type of parsing, the same type of Jinja templating, and you can pass the parameters in, and basically you can use both however you want, and both of them will return a table object that can be passed into future tasks. So we talked about being able to load these files, and we've talked about being able to run these transformations. But one interesting question is, what is the side effect of this DAG? You know, every step along this way is creating a temporary table. What's the side effect if you run this DAG 100 times? And the answer is lots and lots of garbage, which is not ideal. So we want to make sure that you can use the Astro SDK and not have your DBA send you very angry messages at 10 p.m. on a Saturday. And that's where the AQL.cleanup function comes into play. And what the AQL.cleanup function does is allows you to, is that it will live on in your DAG. It will continually check to see if every other task in the DAG is completed. And once every other task in that DAG has completed, it will go through, find all temporary tables and delete them. And so what ends up happening here is that you have a self-cleaning DAG. And as of Airflow 2.0, as of Airflow 2.4, we're actually going to have a DAG teardown option where you won't even need this AQL.cleanup function anymore. You can just actually set the cleanup as the teardown, and you can have full assurance that you won't have any temporary tables littering your Snowflake or littering your BigQuery instances. Next, I want to talk a little bit about the data frame decorator. So we're talking about our Reddit example. You know, so we've taken our data, we've loaded it in, we've now essentially cleaned it, done all the silver level transformations like data deduplication and nulls. And now we want to pass it into our inference model to get predictions on the sentiment analysis. And maybe our inference model lives in, maybe it lives in TensorFlow, where you need to pass it a pandas data frame to actually run it. And that's actually a pretty gnarly thing to do in a lot of scheduling situations is, how do I move data from SQL into pandas, run it, and then get it back into SQL for my reporting table? And so the AQL.data frame operator, one thing that's really cool about it is you can pass in data frames, but you can also pass in tables. And we will, under the hood, magically take care of transforming your tables into data frames to run your data frame option. Not only that, the same output table that exists on the AQL.transform exists in the AQL.data frame. So if you wanted to pass the output of your data frame function back into SQL, you can point it at a table, and we will return a table that can then be passed into future SQL tasks. Another really cool use case for the data frame decorator is for ingestion. So let's say you want to now not pull data from S3, but you want to get live data from Reddit or live data from your internal API, because a lot of companies have internal APIs that may not have an Airflow connector, and you don't want to have to create a whole operator from scratch. So now you have this ability that whatever API you want to hit or whatever thing you want to do, just use AQL.dataFrame, return a data frame object, and now you can actually pass this to your data scientist, where if I'm a data scientist and I want to get fresh Reddit data, but I don't want to know how it's happening, I can import your library, use your function, get a data frame, and either export it to S3 or pass it into future SQL functions, or just do a purely Pythonic flow. But again, this is allowing a small number of data engineers to support a large number of data scientists, and empowering the data scientists to write their own connectors without having to know the internals of what's going on in Airflow. Of course, you can also use the same output table function. And so we're pretty excited about how much we were able to support so far. And of course, the project's always growing. You know, as far as databases, we already have BigQuery, Postgres, Snowflake, SQLite. In a few weeks, we're going to have Redshift support. And we built this in a way that's really easy for us to extend it. So if there's a database you really want, you know, squeaky wheel gets the grease, file an issue, we can talk about it. It's not that hard. It's not that hard for us to add new ones. We also support S3 and GCS, and we support a series of file types. And, you know, there's so much to do. We've already released the 1.0. We just released the 1.0 GA, and that's probably the biggest news of this presentation. Astro SDK 1.0 is out. It's been tested. It's been tested at scale. We're so excited for you to finally start using it. And we really want your feedback. Tell us what features you want. Tell us what bugs you find. Tell us where we can improve this product. We've put a lot of work into the documentation. So I really encourage you to check out the read the docs. You can find the code on GitHub. This is all Apache 2 licensed. So like there shouldn't be any licensing issues. And really the big takeaway messages that I'd love for you all to have from this is that the Astro SDK opens up a whole new class of data scientists and data engineers to Airflow DAG writing experience. It helps you stop thinking in terms of DAGs and start thinking in terms of data pipelines. And it minimizes the overhead of the EL steps so that data scientists can focus on the transformation layer. And of course, again, the biggest news, Astro SDK 1.0 is out. Please go check it out. It's something we put a lot of work and a lot of love into. And thank you to so many people. And I'm sure there are people that I've forgotten on this, but this has been a massive team effort. And I can't wait to take your questions. Thank you so much.
Awesome. Thanks, Daniel. That was a really great overview. I love seeing that use case. I have told you this before, but everybody, I really wish that this was available to me 2 years ago when I was writing data pipelines as a data engineer. It would have saved me lots of time. We do have a couple of questions not answered yet, and I'm going to start with basic one. So how does the SDK deal with scenarios where the query keywords or query language changes between some of the different databases that you're using on the back end? So if you have differences between Snowflake, SQL, kind of in PostgreSQL, how is that managed?
Yeah, I mean, so that's actually a really great question. We really try to maximize the possibility of data agnostic. And one function we actually took out of this presentation, but exists in the Astro SDK, is we have merge and append, AQL.merge and AQL.append, because merges and appends are two of the functions that are the most different between each database. And so we wanted to make sure that if you wanted to do a merge, if you use our merge function under the hood, we will handle all of the differences between how Snowflake handles merges and how BigQuery handles merges and how Postgres handles merges. As much as possible, we wanted to build this in a way that if you wanted to try out a different data warehouse or you wanted to switch off between them, that the Astro SDK, anything that's under the hood for us, we built in a way that can detect the database and try to maximize the possibility that there's no conflicts.
Yeah. I think personally, that's a huge benefit, is alleviating some of that burden on the user to sort of figure out those different nuances. Yeah, that's a great question. Thanks for asking that. Okay, another one. So Ashish asked, he has a use case where he's grabbing data from Redshift and loading it into BigQuery and then combining it, merging it in with some other BigQuery data sets. So his current process for that is sort of default to get it from Redshift into BigQuery with a couple of different steps, since that's not a super natural transition in terms of Airflow right now. So he's asking, can the SDK kind of replace this roundabout method where they're using S3 buckets sort of in the middle and Fivetran to merge everything in and make it more direct to go from Redshift to BigQuery?
So we don't have direct Redshift to BigQuery yet. That's certainly something that we've been talking about. But what we do have is we could at least make it simple where you just do export file. So you just take your Redshift table, export it to S3, and then load file. So you can load it directly back into BigQuery. And so with 2 lines of code, now you have your Redshift to BigQuery. And it's also the case that we can either infer the schema for you, or you can give us a schema object to make sure that the data is the correct schema.
Awesome. Great question. Another one, what is the approach for macros and templating with the SDK functions? And is that something that's documented for use of those operators? Which fields are templatable?
Yeah, so I believe, anything in the SQL queries themselves is, of course, templatable. So anything in the parameters of the function, anything in the SQL query, all of that is Jinja templatable. You can absolutely use your Airflow execution date and stuff like that in those parameters. I I don't recall if we specifically mentioned which of the like function arguments are templatable, but if that's not the case, definitely please post a documentation bug, and that's something we could solve in a very short period of time.
Got it. Oh, and I saw right in the chat a follow-up to our Redshift to BigQuery question. One, maybe I'll pose this more generally. Can you use more than one data warehouse within the same DAG? So
absolutely, absolutely. This is so basically, if you look at it, if you build a DAG with the Astro SDK, first of all, you can build it in a way that you just change one variable, and then that changes the database for the entire DAG. Or you can basically have different steps handling different DAGs. The only thing that's not yet supported is like being able to join a Redshift table and a BigQuery table in a single like query. You might have to still just do like the S3 in the middle for now, but long term, I do think that is something we plan to support, is this kind of feeling that you could pass around data between databases.
Yeah, definitely. Yeah, that's a great question. Another great benefit there, and that there's not a lot of change to the user in terms of implementing that, other than pointing to a different connection. So that's a great question. Have a question on how does this compare to Palantir Foundry? Are you familiar with that, Daniel?
I have no idea. This is the first time I've heard the phrase Palantir Foundry.
Also new to me too. So Xiaoyang, sorry, we don't have a great answer to that one. But interested in learning more about it. So we will definitely look into that. Let's see. This is a good one. So when you're using a data frame function, so any transformations that you're doing in pandas, where is that computation being done? Is that in the Airflow instance? Or if somebody already has their Airflow environment set up to do, use other compute engines outside of Airflow, like something in AWS, is that possible, or how does that work?
So for now, it takes place in the Airflow worker. And if we're talking like a couple of gigabytes, that's like, we haven't run into too many issues with that so far. The ability to do it in different Python environments is certainly something that we'd be open to discussing. I don't want to make a promise on it, but it's certainly something that like could be really interesting. And there's no so for now it is on the Airflow worker, but that could be something that we could discuss.
Yeah, great question. And I think we'll get a link to the repo that you had in the slides and throw it in the chat in just a second here, but that's certainly somewhere where people can, submit issues and feedback and things like that. Let's see. Daniel, do you mind going back to the slide where you talk about the supported databases and file systems? We've gotten a couple of questions.
Yeah, absolutely.
Just want to leave this up for a second for hopefully to answer all of them in case I've missed some in the chat. We did get one specifically about do you support Exadata and Teradata? Full server.
So that kind of goes back to the squeaky wheel gets the grease, where like we're going to be paying very close attention to the issues that get raised and the amount of comments and upvotes those issues get. Like that will very directly determine what order we support what databases.
Yeah. Great question. It's a good one. Does Open Lineage work with Astro SDK functions?
That is on the roadmap, and like we are working directly with the Open Lineage team to make sure that there is a very first-class support between Astro SDK and the Open Lineage, to the point where like using Astro SDK will make for a very clean Open Lineage story.
Great. Awesome. And sorry to Daniel I'm not doing a very good job of grouping these in a
It's fine, it's
order, so
fine.
we're going to go back and forth topics.
Yeah.
These are all really great questions. Everybody keep them coming. Rigo asked, is there any kind of integration with Spark for this? So sort of same question. We already kind of answered that with the backends, but we'll
the only answer I can give is not yet. Like I don't want to make any promises, but it's certainly something Spark support is certainly something I would be personally interested in, but it's not something I can't give a timeline for that.
This is it's a big project with lots of work going on. So these are all really great questions, stuff that we're super interested in hearing feedback on, but certainly lots of exciting work to come as well.
Yeah, no, of course, by the way, keep in mind, like the questions you all are asking here, we're going to be like rewatching this video and saying, they're asking about Spark. We should talk about Spark. Like those, like being able to get this kind of feedback is really valuable to us.
Yeah, great. And another question, maybe we can go back to one of the example code slides for this. Can you just clarify how connections work to kind of your backend SQL engine or data warehouse? And
so
if you have multiple, if you're working with multiple databases in the same DAG, how do those dependencies work?
Yeah, absolutely. That's a great question. So one thing you'll notice in this DAG is that you'll notice that like you only need to name the connection like once, which is like a huge benefit of Astro SDK versus traditional Airflow, where you have to put the same connection ID over and over and over. So if you have like a SQL query that takes 3 tables, we will actually take the connection ID of the first table and like put it into like we will use that connection ID by default. So we are able to kind of like infer. As to the question of like, mixing apples and strawberries, it's not quite there yet, where if you try to do a merge with 2 connections in the same task, that might be something we don't yet support. But in the same DAG, of course, you can absolutely have like a series of transformations happening in BigQuery and in parallel a series of transformations happening in Redshift. And then you just kind of have to decide how you merge those together. And that could also, by the way, be a use case for the data frame stuff, where you might convert one of those into a data frame and then pass that into like the other database, depending on how large the size of the data is. So either that or some form of blob store as an intermediary.
Great, that's helpful. Another good one, and you may have had this in a slide, but can you show the resulting tree or graph view for these DAGs? I think the question is whether or not these functions show up just as any other Airflow task would. The answer is yes.
Oh yeah, the answer is absolutely yes. So this is an actual DAG created with the Astro SDK. So you can have multiple inheritance. You can have like the only thing that's a little interesting is the fact that the cleanup will be kind of running as this side task. But other than that, every single step of these functions is its own Airflow task with its own logging, its own like parallelism. It's like this is a very one-to-one integration with Airflow.
It's a great question. Okay, I think that we've gotten most of them. Do you have a couple more minutes? So if I missed your question, feel free to throw it in the Q&A. Still out there in the chat. These are all really great. Love to see this engagement. Thanks for pulling up that slide. I did throw the link to the repo as well in the chat. Those. Awesome. I'm not seeing anything else pop up for now, so I think probably good to go. Oh, said maybe questions in the general chat. Oh, I see. One last one about the merge function.
Yes.
There you go. I'm not sure exactly what you mean by how smart is the merge function. That's a great question. The example was if you had many small JSON files to merge into partitions. So I guess maybe if you could just talk generally about kind of how the merge function works and what the different use cases are there.
Yeah, sure. Let me pull up the code for the merge function, or let me pull up an example of the merge function just to kind of show people what it looks like. Because I will say that the support is somewhat simple, but it handles at least what I would consider decent use cases, which is the AQL.merge, AQL.append. Basically, it's like you have the target table, the source table, you give it the conflict columns, and you give it the conflict strategy resolution. So the three of those, of course, being update, ignore, and exception. So update is you put in the new value, ignore is you put in the old value, you keep the old value, and exception is, hey, like there shouldn't be any merge conflicts at all. So it is a somewhat basic support, and we purposely did it that way to see if people actually like how in depth do people actually want this function to get. And so as far as like having lots of partitions, we don't yet support that. But if you have just like a very simple merge use case, that is what we currently support. And we also support append for if you don't care about conflict resolution at all.
Great. Thanks for going over that. All right. Well, thanks, everybody. Again, love to see the engagement here. We're super excited about this project, so definitely stay tuned for more updates in the future. Again, for everybody who registered, so we will send out not only the recording, but those links that Daniel had in the slide of additional resources. So the read the docs. We have a detailed guide on how to use this for ELT use cases, as well as the blog posts that Mike linked in the chat. All of that stuff will be included in the recap so that you have links to those. We hope that you are going to use those to go play around with it yourself and see how it works. And we definitely welcome your feedback. So
thank you all so much.
Yeah, thanks everybody for joining, and we hope to see you next time. Bye, everybody.